Okay, just we'll glance up what we discussed yesterday. I'll just go with some questions, just revision questions of yesterday part. Hope everybody will answer correctly. Ready? Ready to answer, all of you? Okay. No reply from your side. I'll go with yeah, good morning all. Now tell me, what is electric current? What is electric current? Hope everybody will answer correctly. This is very important. Go with simple answer. Now same questions were asked yesterday also. Now same thing I'm asking today. Okay, just type without seeing. Good, Varalakshmi, very good answer. And where is the formula? Hi, Fresh Idea channel. Thanks for your visit. Thank you so much for attending my live session. Thank you. Yeah, Varalakshmi, it's correct. I is equal to Q by T. I is equal to Q by T is a formula to find out the electricity. Yeah, Nandita, Varsha, Rajni, and Gayatri. Very good answers. And two of you left the formula. Just add the formula. Okay, meanwhile, you be answering what is the equivalent value of Coulomb. What is the equivalent value of Coulomb? Yeah, Arpita and Gayatri, formula is good. Okay, now tell me what is the equivalent value of 1 Coulomb. Yeah, Kirti, absolutely correct. Yeah, 10 raised to 6 into 10 raised to 18, correct. Okay. Now, what is the equivalent value of each electron? What is the equivalent value of each electron? Yeah, Kirti, it is good. Correct for previous question. Yeah, Nandita, answer is 1.6 into 10 raised to. You gave plus 19. That's wrong. Yeah, Priyanka, that is correct for previous question. That is for coulomb. 1 coulomb is, the value is 6 into 10 raised to 18. Good. But I already gave one more question. What is the value of each electron? Harshita, it's incomplete. Yeah, Kirti, now it's correct. 1.6 into 10 raised to value of each electron. Good. Yeah, Jini, Harshita, correct? Okay, morning itself, poor network. Here in my place too, network is very poor. Yeah, Vandana, try to answer. Try to answer for the questions. Yeah, Priyanka, it's correct. And Priyanka has become very expert in typing, and she come to know which is an exponential, and she is rising up the numbers as an exponential. Good, good, Priyanka. Okay, my next question is, what is electric potential? Give the formula. What is electric potential? Give the formula. Here in my home, the network is fluctuating. Sometimes it connects and it will go low. So you may have break in my voice. Now look at the question. I just typed the question. Go through the question and try to answer. So along with the definition and formula, try to give SI, also give SI unit for the terms given in the formula. And the definitions, Harshita, Rajni, correct answers. Instead of positive, just try to give charged. Yeah, Gayatri, Kirti, correct answers. Okay, Nandita, you gave SI unit for V. And Kirti left for Q. And even Revati gave SI unit for V, that is volt. I told to give the SI unit of the components present in the formula. Okay. So what are the components present in the formula? V, W and Q. The SI unit of V is volt. The SI unit of W is work done is Joule. And the SI unit of Q, the electric charge is Coulomb. Okay. Now, what is Ohm's law? And give the formula and its SI units. What is Ohm's law? Give the formula and its SI units. Yeah, Priyanka. And its SI unit. And later I'll commence the session. Try to answer this question fast. Let me move on to the continuation of the study class. Where is Newton, Vandana? For what you are giving Newton? Newton is not here. Newton is not existing in this formula. Try to give the definition first, Ohm's law, then formula, and then SI units. Okay? Okay, Ishwarya, try to give definition first. Yeah, Nandita, it's correct. But before the professional, you can give directly proportional. Absolutely correct, Priyanka. Now all of you look at Priyanka answer. Now definition, formula and the SI units. Everything it is there in a single statement. And even Kirti. Before Priyanka, Kirti has answered completely. Very good, Kirti. Shubha, you don't give some non-related statements, okay? Now, what we were discussed yesterday, you try to answer in the same way, not in some different way. Revati, answer is correct, but where is the SI units? Where is SI unit? You just gave the expanded word, but you didn't give the SI unit, Revati. Yeah, Nandita, SI unit is correct. Okay. Now till here we discussed yesterday. Now shall we continue the session? The correct SI units are correct. Okay. Now Ohm's law is the potential difference is directly proportional to the current flowing through the conductor, and V is equal to IR, or I is equal to V by R. So you can change the formula as per the requirement. Now in this formula we come across R. What is R? R is resistance. And how the resistance is related with the current? Okay, I'll share the formula. You just have a idea on that. Now what does this formula indicates? How current I and R is related? Were they directly proportional or indirectly proportional? Okay, my question is, now how current and resistance are related? Just now I shared the screen on the formula. I is equal to V by R. Okay. Now how I and R are related? Yeah, Rajni, it's correct. It's correct. Any other way of conveying your answer? How current and resistance are related? Rajni gave one statement, even that is correct. Any other statements on this question? Okay, it's very simple. Current is always inversely proportional to the resistance. I is equal to V by R. That indicates current is directly proportional to the voltage and inversely proportional to the resistance. Very good, Priyanka. Excellently correct statement. Very good. Now, just now I told current is directly proportional to the voltage and inversely proportional to the resistance. What does it indicate? If resistance is high, the flow of the current is less. If the resistance is low, the flow of the current is high. Hence, the current is inversely proportional to the resistance. And How the conductors, alloys, insulators show the resistance. The conductors like silver shows very least resistance because they are good conductors of the electricity. Hence, the resistance is very less. And alloys shows moderate resistance, and insulators shows high resistance. Insulators shows high resistance. That means if the insulators shows high resistance, what will be the flow of the current? What will be the flow of the current? It is high or low or nil. Now Pallavi and Rajni try to change the statement like this. Current is directly proportional to the voltage and inversely proportional to the resistance. Okay? Even your statement is correct. But this is very simple. No, Nandita. In the insulators, the resistance is, yes, it's high. Very good answer, Nandita. Very good. So, it's very simple. In insulators, the resistance, sorry, I asked the flow of the current, right? Nandita, what did I ask? What about the flow of the current? Okay, I don't know what you're answering. Even Kirti, Priyanka and Nandita, whether you were answering for resistivity or the flow of the current. Okay, high in the sense, what is high? The flow of the current or the resistance? Okay, everybody giving the answer as high. What is high? Then absolutely wrong, Kirti. Very wrong concept. What I told? Insulators have high resistivity. High resistivity. Insulators will have high resistivity. Then what will be the flow of the current? Yes, Priyanka is absolutely correct. The flow of the current is nil or very minute in insulators because they have very high resistivity. If there is high resistivity, definitely the flow of the current is so difficult and it cannot transfer the electrons. Okay, I have the network. No problem in my place now. Yeah, don't know. Even in the morning we have the network problem. Okay, it will be rectified. Let me see for a few more minutes. Now, the conductors shows less resistivity, high conductivity. Alloys shows moderate resistivity, moderate conductivity. Insulators shows high resistivity, low conductivity of the current. Remember these statements. It will be asked for your board exam. Okay, next. And what were the factors related to the resistance? What were the different factors related to the resistance? It can be given by the formula R is equal to L by A. R is equal to L by A. Okay, now I just changed my location. Okay, now. Okay, few were hearing me and few were not able to hear me because today at starting I had a network problem, but now I don't have any problem. I have network, maybe in your place, and today it's little bit cloudy too. Because of that, you may having the problem. Okay. Yeah, and few people were able to hear. Okay, you check here and there, it will be clear. Now, the resistance is directly proportional to the length of the conductor and inversely proportional on its area of cross section, and even the resistance is depending on the nature of the material. This is very important for your board exam. They'll ask for the examination. Okay, resistance is directly proportional to its length, inversely proportional on its area of cross section, and it depends on the nature of the material. Okay, I have no problem because my network is good here. And meanwhile, R is equal to rho L by A. What is this rho? This rho is called as electrical resistivity. Electrical resistivity of the material. And the SI unit of resistivity is ohm meter. Ohm meter. For resistance, the SI unit is ohm. For resistivity, the SI unit is ohm meter. Okay. Okay, clear. Look at Aishwarya Priyanka. She can able to hear both of you from same area, right? Okay. Now, if the concept is cleared, now tell me which were the factors which depends on resistance. Okay, put in a words, simple words. Factors, which were the different factors depending on the resistance. Okay, okay, okay. Okay, Priyanka. Okay, now what were the factors which resistance depends on? There were three factors, right? Which were the three factors? I gave the formula R is equal to rho L by A. Okay, now you just put in a words. Which were the different factors which is resistance is depending on? And for your board exam, the complete chapter will be there. Okay, not even a single statement will be deleted. Complete chapter will be there for your board exam. Okay. Okay, put in words. No need to give me statement. Okay. Absolutely correct, Priyanka. Wonderful answer. Now, resistance is directly proportional to the length, inversely proportional on its cross section, and depends on nature of the material. These were the three factors, and one more factor is there. It is directly proportional to the resistivity, that is rho. Okay, rho is, the SI unit is ohm meter. It is ohm meter. Okay. Based on this, the application question is based on the resistivity. Tungsten is used in making filaments of electric bulb. Why? Tungsten is used in making filaments of the electric bulbs. Why? Yeah, Rajni, half answer. You gave only half answer. Yeah, Arpita, correct? Okay. Tungsten is used in making the filaments of electric bulbs because tungsten shows high resistivity and high melting point. Remember, tungsten is used in the bulbs because it shows high resistivity and high melting point. It can tolerate high amount of electric power, and thus it converts into heat and then into light. Hence, tungsten filament is used in electric bulbs. Okay, clear? And the next application question based on resistivity is why copper is usually used for electrical transmission lines. Why copper is used as electrical transmission lines? Because the copper shows less resistivity and hence the conductivity is high. Hence it is used in electrical transmission lines. So these two questions will ask for your board exam. Tungsten is used in the bulb because it shows high resistivity and high melting point. Copper is used for electrical transmission lines because it shows less resistivity and high conductivity of current. Hence it is used in electrical transmission lines. Okay. Okay, I didn't get any reply if it is cleared or not. Okay, these are very important questions. There will be one more application question. Why alloys are used in making heating devices, electric iron and toasters? Why alloys are used in heating devices or electric iron box or toasters? The answer is generally alloys shows higher resistivity than the metals, and alloys do not oxidize readily at high temperature. Hence, alloys are used in heating devices. Okay, Nandita, I'll repeat all the three concepts. These three questions are very important for your board exam. What were the three questions? Why tungsten filament is used in electric bulb? The answer is tungsten filament shows high resistivity and high melting point. high resistivity, high melting point. Hence, tungsten is used in electric bulb. And very immediately I will ask these 3 questions. Now everybody ready to answer? Okay. After getting reply for all these 3 questions, I'll move on. Okay. Now, the second question. Why copper wires are used for electrical transmission lines? Copper is a very good conductor of electricity because it shows less resistivity. Copper is a good conductor of electricity because it shows less resistivity. And the third question, why alloys are used in making heating devices? Alloys are generally shows higher resistivity than other metals. And alloys do not oxidize readily in high temperature, or alloys do not burn readily at high temperature. Hence, alloys are used in making heating devices. Now, all these 3 questions completely related on resistivity. Tungsten has high resistivity, copper has less resistivity, alloys has more resistivity than the metals. Okay, completely all these 3 questions depending on resistivity. Okay, now tell me the answer for these questions. If you answer so fast with these 3 questions, I'll move on to the next concept. Why tungsten is used in electric bulb? Why tungsten is used in electric bulb? Why tungsten is used in electric bulbs? Kirti, for liquids we'll call boiling point, okay? For solids like metals, we'll call it as melting point. Only for the liquids, we call it boiling point. For solids, we call melting point, okay? Not boiling point, it's melting point, Kirti. Yeah, Harshita, it's correct answer. Yeah, Aishwarya, it's only half answer. What about other half? Okay, correct answer. Yeah, Nandita, it's correct answer. Now I think it's clear for Nandita. Okay. Okay, my next question is, why alloys are used in making heating devices? Why alloys are used in making heating devices? Why alloys are used in making heating devices? Yeah, Revati, it is correct for previous question for tungsten. Okay. Now I already gave the question, another question. Why alloys are used in making heating devices? Yeah, Manjula, it's correct. Sorry, Harshita, it's correct. But you should add up one more statement. Okay, let me see. Anybody else will answer? Yeah, it's Priyanka answered completely. This is the absolute answer. Now, the alloys shows high resistivity than the metals. This is one point. And they do not oxidize readily at high temperature. This is other point. These 2 points are important to answer for this question. Okay. Now Priyanka answered perfectly. And Harshita, you want to go with another statement also. Oxidize or burn. So alloys easily cannot burn at high temperature. Okay. Next, why the copper is used in electrical transmission wires? Why copper is used in electrical transmission wires? And even aluminium. The copper or aluminium are generally used for electrical transmission lines. Why? Yeah, Rajni, even you gave a half answer and you want to give another one statement. Yeah, Harshita, now your answer is complete. Good, Harshita. Varalakshmi, you look at your answer, okay. It is good conductor and what is that? Shows less electricity. If it is good conductor, how come it shows less electricity? Yes, it's Priyanka answered correctly. Copper shows less resistivity and hence it shows high conductivity of electricity. Good, Priyanka. Okay, now we'll move on to the next concept. How the resistance of systems of resistors were arranged. Now the resistors can be arranged in series and in parallel. And what is the concept between the series and parallel? Different resistors arranged in series and different resistors arranged in parallel, and that is called resistors in series, resistors in parallel, more than one resistor. Now how the resistors were connected in series and in parallel? The formula for resistance. Resistance is directly proportional to the rho, directly proportional to the length, and inversely proportional to its cross section. And this is R1, R2, R3 different resistors arranged in series. One is located to side of the other. And these resistors are connected in electric circuit. And this is resistors connected in parallel. These are the resistors connected in parallel. Now look at this image. You find the difference between first one and the third one. Here in parallel resistors we have to connect. Look at here. In parallel connections, same voltmeter is connected to all three resistors because in parallel, but the current will differ. The current will differ. Is right if not audible. In the first image, we come across the 3 resistors connected to 1 voltmeter. Why? There is no difference between resistors. All the 3 resistors have same resistance. Hence, it is connected to 1 voltmeter. Okay. Each resistor is connected to separate voltmeter because the resistors showing different resistance. Hence, it is connected to different voltmeters. And in the parallel connection, only 1 voltmeter is connected because all the 3 resistors shows same voltage. It shows same voltage. Hence, 1 voltmeter is connected in parallel connection. What is the difference between series and parallel? In the series, same current is passed through all the resistors, and in the parallel, same voltage is passed in all the resistors. Okay, all these were the important concepts which may be asked in different way, twisted way, and will be given for your examination. Okay, at least now when I come back here, I think it was clear. And the formula to find out the resistance when it is connected in a series, that is R is equal to R1 plus R2 plus R3. This is the formula. And when the resistors are connected in parallel, what is the formula used? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. If it is cleared, shall I move on to the next concept? Heating effect of electric current. Shall I move or should I repeat? Okay. Different resistors are connected in series. Same current is passed with different voltage. Hence, in series, different voltmeters are connected to resistors. In parallel, same voltmeter is resistor, but they have same voltage, but they show different current. And the formula to find out the resistance in series is R is equal to R1 plus R2 plus R3. And in parallel, it is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, we have another 2 concepts, that is heating effect of electric current and electric power. I'll complete this so that you can view again when you recover the good network. Okay, I'll just proceed. Now, how the heating effect of the electric current can be observed in electrical appliances. When the current is passed through the conductors and electrical appliances, first they'll heat up and then it will convert into light energy or heat energy. When electric current is passed through the electrical appliances, it converts into two forms. That is, it converts into heat first, it is common, and then this heat can convert into light energy, and sometimes it remains as heat. This heating effect of the electric current is known as Joule's law of heating. Joule's law of heating. Now, what is the formula used? H is equal to V into I into T. V is voltage, I is current, T is time. So, the heating effect can be calculated using the formula H is equal to V into I into T. For the same thing, if you apply Ohm's law, then H becomes H is equal to I square R into T, and this is called Joule's law of heating. Now, how you can explain the Joule's law of heating? The Joule's law of heating law implies the heat produced in resistor is directly proportional to the square of the current, directly proportional to the resistance, directly proportional to the time for which the current flows. And this is called Joule's law of heating. The formula is H is equal to I square R into T. This is called heating effect of electric current. And the next one is electric power. What is the application of Joule's heating in a fuse? As a result of Joule's heating in the fuse, when there is a fluctuation in an electric current, it allows the wire to fuse so that it disconnects from the circuit and prevents short circuit. It prevents short circuit. And the last concept is electric power. The rate of doing work is called power. The rate of doing work is called power. And what is the formula? P is equal to V into I. And if you apply the Ohm's law, then P is equal to I square R. Okay, now this about the complete chapter on electricity. We left with numericals. We'll discuss in the class, and what were the different numericals and how to solve, we'll discuss in the class. Now this completes the electricity chapter, and what we discussed today, the application level questions will be asked for your board exam. Okay, now all of you go through the link once again and understand the concepts and get prepared for tomorrow. Okay, tomorrow I'm going to ask questions. The same link when you get good network. Okay, everything it will be recorded here. You can go through once again, and if you have any doubts, please convey now. If not, we'll wind up the session.